Hey, so I'm going to be solving a bunch of AS level physics questions in this video. I don't know why people find AS level physics hard. It's not hard. It's basically tricky. It's challenging that you have to think out of the box. It's not always going to give you the answer that you've learned or the formulas. You have to manipulate the formulas and your thinking process. So I'm going to tell you that AS level physics is not at all hard. It's just manipulation of what you've learned. So let's start solving a bunch of questions, and I'm going to show you that how to think while solving AS level physics questions. Okay, so a hot air balloon floats just above the ground. Okay, it's floating above the ground. For physics, I don't know why people find it hard. You just have to convert these lines that are written into formulas and into a way of thinking. ठीक है, the balloon is stationary. अब now a normal person might think, okay, it's stationary, it's fine, just let's read the other thing. But me, what I'm gonna do is I'm gonna know if it's stationary, that means the forces are balanced. So that's the thinking process. Okay, you have to convert every word you're reading that's important into something related to the formulas. Okay, forces are balanced. That means upward force equals to your downward force and is held in place by a vertical rope as shown in figure 2.1. So now, since I know the forces are balanced, I don't know what the question's asking about. So the dynamics should be very clear in my mind. I know there's a rope that's trying to pull it downwards. Okay, the rope is trying to pull it downwards. So there's gonna be a downward force by the rope. And then I know since it's a balloon, it's gonna have a weight. And weight is always downward. So there's gonna be a downward force of the weight. Okay, this one's the weight and this one's the force that's gonna be with glue I've shown, that's gonna be applied by the rope. Okay, now I'm done with the two forces. Now I have to think in terms of other forces. I know since my two forces are acting downwards, this one force and this one force. Since it's stationary, that means forces are balanced. And if forces are balanced, this means there must be an upward force acting as well, which I don't know. So I know there's a force, I don't know the type of force, but I know there must be some air resistance, or air resistance does not act on stationary objects, so there must be an upthrust, uplift force that's acting upwards. Okay, that's my thought process until now. The balloon has a weight of this. Okay, weight acts downwards or upwards? Downwards. So the red force, which I have said is the weight, is gonna be 3.39 into 10 raised to power 4 newtons downwards. The tension in the rope is this. Okay, the tension in the rope is trying to pull it downwards. Okay, because tension is always a pulling force. Tension is not a pushing force. For example, if you have a rope, one person is here and one person is here. Okay, you try to pull the rope on this side, the tension in the rope is going to be towards this side. Okay, remember, this balloon is trying to pull the rope upwards, the tension in the rope is downwards. You got to think in terms of forces. I have a distinction in O-levels physics, and that's how I operate. That's why I'm sharing this with you guys. So now, upthrust U acts on the balloon. Okay, we know there's going to be upward force. The density of the surrounding air is this. We're given with the density and we're told that we have a force that's called upthrust. Now, I know one thing. What do I know? I know the formula of upthrust. I quickly write my formula. Upthrust equals to rho Vg. Okay? And I'm given with the rho as well. Now I can find the volume of the balloon because I know what's going to be my upthrust. These two forces combined is going to be equal to my upward force, because downward and upward forces are balanced because my object is stationary. Okay? Keeping all the forces in mind. This force, this tension, they've told me it's 4.00 into 10 raised to power 2 newtons. Now the sum of these two forces is going to be equal to my upward force, because downward and upward equal. Basics clear. Okay? Ab calculate the volume. I promise I didn't know that they asked about the volume. I just told you that from the information that we're given, we can find the volume, and that is what they've asked us. Now for this, first we need to find the upthrust. Okay? So upthrust equals to, Upthrust is the upward force equals to the two downward forces. The first downward forces are weight plus the second downward forces are tension. Okay? So the sum of weight and tension gives me upthrust. What's my weight? 3.39 into 10 raised to power 4 plus 4.00 into 10 raised to power 2. Okay, 3.39 into 10 raised to power 4 plus 4.00 into 10 raised to power 2, and that gives me my upthrust comes out to be 34300 newtons. That's my upthrust. And now I know the formula of upthrust, that upthrust equals to rho Vg. Now this was my upthrust that came out. So I put my upthrust over here, 34300 equals to rho. I'm given with a rho. This one's my rho, 1.23 kilogram per meter cube. In physics, you got to be sure about the SI units. While reading a value, you need to focus on the SI units. That is it in base SI units? Yeah, it is. So 1.23 kilogram per meter cubes times my volume I don't know, times my gravitational field strength, which is 9.81. Just rearrange it. It's gonna be 34300 divided by 1.23 times 9.81 equals to my volume. Let's see what this gives us. Upon 1.23 times 9.81, and this comes out to be 2842. Now I look at the significant figures in the question. Look, three significant figures, 4.00, three significant figures, 1 2 3, 1 2 3. My answer now needs to be in three significant figures at least. So I'm going to round this up to three significant figures, which is 284 and then 0. So 2840 meter cube. Okay? I hope you get what I tried to explain. The balloon is released from the rope. Calculate the initial acceleration of the balloon. Okay? Now what's happening? This balloon is released from the rope. Now balloon is accelerating upwards. Okay? It's accelerating upwards. That means the resultant force is in the upward direction. So now this rope is cut, balloon starts to move upwards. That means the forces are unbalanced because the balloon is accelerating. Now the force of tension that was holding it downward, the tension from the rope, it's now gone. The only force that now you have is your weight versus upthrust, and upthrust wins because upthrust is greater in value. That's why it moves or accelerates upwards. The forces are unbalanced now. So now to find the acceleration, first we write the basic formulas. Force net, meaning the resultant force matlab upward minus downward, equals to mass times acceleration. Okay? Now what is my force net? My upward minus my downward. What was my upward force? Upward force was my upthrust. What was my upthrust? Upthrust is, this was my upthrust, 34300. 34300. This is my upward force minus my downward force. Resultant is upward minus downward. Okay? Opposite forces को subtract कर दो, we get the resultant. So this is basically my upward force. I subtract from it the force that's now downward, and that's only the weight because my tension is gone now. So 3.39 into 10 raised to power 4. 3.39 into 10 raised to power 4. Let's see what my resultant force comes out to be. Okay, 34300 minus 3.39 into 10 raised to power 4, and that gives me 400 newtons. Now 400 newtons equals to, resultant force equals to mass times acceleration. Acceleration I don't know. Mass is, what's going to be the mass? We're given with the weight. Where's the weight? This one's the weight. W equals to mg. Weight is 3.39 into 10 raised to power 4 divided by g, which is 9.81, equals to your mass. ठीक है? So we plug in 3.39 into 10 raised to power 4 divided by 9.81 is going to give you the mass. Now simply find the value of A. A equals to 400 times 9.81 times 3.39 into 10 raised to power 4. I hope you're understanding what I am trying to do over here. 3.39 into 10 raised to power 4. And that gives me 0.1157. How many significant figures I choose? I look at my question, all given to 3 significant figures. So I also do it till 3 significant figure. 1 significant figure, 2 significant figure, 3 significant figure. ठीक है? 0.116 meters per second square. I'm good to go. Now questions like these are the trickiest. These are the questions where I guess the majority loses marks, because the formula and everything everyone can do. But over here you require thinking. And I'm trying to give you the exact thinking process that's good. ठीक है? The balloon is stationary at a height of 500 meter. मतलब at a height of 500 meter, now again the upthrust and weight are balanced. ठीक है? Or the air resistance or whatever forces are balanced. The word stationary, for if you're studying physics, should just mean to you balanced forces. ठीक है? This is my balloon. ठीक है? This is my balloon. And now it has weight acting on it, it has upthrust acting on it, and since it's accelerating upwards, it's moving upwards, so there's another downward force acting on it. That's your air resistance. This means at height 500 meter, देखो अपथ्रस्ट हमें पता है कितनी थी, वेट हमें पता है कितनी थी, जो एडिशनल फोर्स आई वो थी एयर रेजिस्टेंस. मतलब 500 मीटर की हाइट पे एयर रेजिस्टेंस और वेट का सम दोबारा इक्वल हो गया अपथ्रस्ट के. समझ आ रहे? व्हाट आर वी डूइंग? क्या हो रहा है? 500 मीटर पे वो दोबारा स्टेशनरी हो गया, मतलब डाउनवर्ड फोर्सेस दोबारा इक्वल हो गई अपवर्ड फोर्सेस की. आई होप यू आर गेटिंग. A tennis ball is then released from rest and falls vertically from the balloon. Okay. अब इस balloon की ground से height है 500 meter. Okay. And I now release a tennis ball from the balloon downwards. जब हम उसे बैलून से डाउनवर्ड्स रिलीज करेंगे, उसकी इनिशियल एक्सेलरेशन क्या होएगी? 9.81 मीटर्स पर सेकेंड स्क्वायर. ये उसकी इनिशियल एक्सेलरेशन है. इस हाइट से वो फॉल कर रही है. खुद ही समझदार हो आप लोग. अ पैसेंजर इन द बलून यूजेस द इक्वेशन v square equals to u square plus 2as to calculate that the ball will be traveling at a speed of approximately this when it hits the ground. Explain why the actual speed of the ball will be much lower than this when it hits the ground. Because उसकी acceleration change होगी. अब आपको इस तरह के questions, I know they might trick you, but what's happening is try to understand. ये बहुत ज़्यादा height है. इतनी height से जब वो गिरेगी, so what will happen over time? उसका resultant decrease होगा. अब जो student है ना, जो passenger है, वो consider करे कि उसकी acceleration, ये जो formula में A है ना, ये continuously 9.81 है. मतलब हर सेकेंड वो 9.81 मीटर्स की स्पीड से इंक्रीज़ हो रहा है. रियलिटी में ये नहीं है. रियलिटी में एक्सेलरेशन डिक्रीज़ हो रही है, क्योंकि एयर रेजिस्टेंस भी तो है. समझ आई? और अब आपको एक बात समझ आई कि उन्होंने ये बात पहले क्यों बताई है. द बैलून इज स्टेशनरी एट अ हाइट 500 मीटर. दे आर ट्राइंग टू टेल अस कि एज इट गोज अप इट फेसेस एयर रेजिस्टेंस. दैट्स व्हाई इट बिकम्स स्टेशनरी. एयर रेजिस्टेंस की वजह से डाउनवर्ड का जो सम है वो ज़्यादा हो रहा है. So now what will I say is that, listen, this equation is for uniform acceleration. बॉल की यूनिफॉर्म एक्सेलरेशन सिर्फ इनिशियली होगी, ठीक है. सो आई विल टेल हिम दिस इक्वेशन applies to uniform acceleration only, whereas as the ball falls, air resistance acts on it. Keep your explanations clear, ठीक है. No matter if you have to draw a line over here as well and write, no matter, that does not matter, but what you're trying to say should be clear, ठीक है. The ball falls, air resistance acts on the ball. Okay, अब air resistance ball पे act हुई, so the resultant force decreases, hence the acceleration decreases. Hence, the acceleration also decreases. ठीक है? This equation applies to uniform acceleration, whereas the ball falls, air resistance is going to act on it, so the resultant force is going to decrease, so the acceleration is also going to decrease, not remain constant at 9.81, not remain constant at 9.81 meters per second square. That's all. Moving to the next part. Before the balloon is released, okay, the rope holding the balloon has a strain of this. The rope has an unstretched length of this. The rope obeys Hooke's law. A lot of information to absorb. Show that the extension in the rope is this. Okay. Now, if I say that there's a lot of information, I simply just have to put this information into my formulas and get the extension. I know how do I get the extension. I know the formula of my strain has extension. Strain equals to my change in length upon my original length. Okay. Now I need this change in length, okay? Strain is this. I guess that's simple enough. And the original length is this. Simple. Strain, which is 2.4 into 10 raised to power negative 5, multiplied by original length, which is 2.5. It's going to give me my change in length. And change in length is going to be extension. So this needs no thinking, just formulas. 6 into 10 raised to power negative 5. Okay. But do you see one thing? It's 6 into 10 raised to power negative 5. But are you noticing something? The examiner didn't write 6 into 10 raised to power negative 5. Why he didn't? He said 6.0. Small details, but important. Okay? Because you have to give it to two significant figures. So you also not trying to do what he has not done. 6.0 into 10 raised to power negative 5. Two significant figures. So the answer is also in two significant figures. Calculate the elastic potential energy in the rope. Elastic potential energy is going to be that EP equals to half kx square. I think this is one of the formulas. And other formula is EP is equals to half fx. Okay? So you can use any formulas. You have the force as well. Okay? The force, it was given the tension in the rope in the beginning. So force into extension times divided by 2. What was the force in the beginning? The tension in the rope, it was 4 into 10 raised to power 2 newtons. So my half times my force is 4.00 into 10 raised to power 2 newtons times my extension. My extension just came out to be 6.0 into 10 raised to power negative 5. Plug this all into my calculator. 4.00 into 10 raised to power 2 multiplied by 0.5 gives me 0.012 joules. Okay, last part, is always the hardest and the trickiest for everyone. But we're gonna read it together and learn to think. Physics is all thinking. Like, if you exclude the formulas, the remaining questions, they're about thinking. And if you exclude the definition parts. So that's the hardest, thinking. The rope holding the balloon is replaced by a new one of the same original length, okay, and cross-sectional area. Length is same, area is same. The tension is unchanged, and the new rope also weighs Hooke's-law. The new rope is made from a material of a lower Young modulus. Okay. ठीक है. Young modulus equals to stress upon strain. ठीक है. That means if the Young modulus is lower, ठीक है, that's how I am thinking. I have not read the question. If the Young modulus is lower, ठीक है, अब I'm gonna replace the values. Young modulus equals to force into my original length over my cross-sectional area into my extension. ठीक है, they've told that the tension is unchanged. So tension is unchanged. The balloon is replaced with a new one of the same original length. Original length is unchanged and cross-sectional area is unchanged. That means if I'm lowering Young modulus, what's happening? देखो, अगर फोर्स सेम है, अगर लेंथ सेम है, अगर एरिया सेम है, तो चेंज क्या हो रहा है? अगर यंग मॉड्यूलस नीचे जा रहा है तो दैट मीन्स एक्सटेंशन चेंज हो रही है. समझ आए? सो इफ यंग मॉड्यूलस डिक्रीजेस, सिंस एक्सटेंशन एंड यंग मॉड्यूलस आर इनवर्सली प्रोपोर्शनल, द एक्सटेंशन इन द स्प्रिंग इज इंक्रीजिंग. समझ आए? Extension in the spring is increasing because the Young modulus is decreasing, and I can see that ये inverse का relation है Young modulus और extension में. और अब होगा क्या? Now what's gonna happen is that there's gonna be more extension. State and explain the effect of the lower Young modulus on the elastic potential energy of the rope. देखो, अब elastic potential energy का formula लिखो. EP equals to half Fx. मेरी बात सुनो, अभी हमने कहा जो हमारी एक्सटेंशन है वो इंक्रीज़ हो रही है. यंग मॉड्यूलस के डिक्रीज़ होने से एक्सटेंशन इंक्रीज़ हो रही है. तो एक्सटेंशन इंक्रीज़ हो रही है, ठीक है, एक्सटेंशन इंक्रीज़ हो रही है. एक्सटेंशन और इलास्टिक पोटेंशियल एनर्जी का क्या रिलेशन है? एक्सटेंशन इलास्टिक पोटेंशियल एनर्जी का डायरेक्ट रिलेशन है. तो मतलब अगर एक्सटेंशन इंक्रीज़ हो रही है तो इलास्टिक पोटेंशियल एनर्जी भी इंक्रीज़ होगी. तो स्टेट एंड एक्सप्लेन द इफेक्ट ऑफ लोअर यंग मॉड्यूलस ऑन द इलास्टिक पोटेंशियल एनर्जी इज़ दैट I explained it to you that elastic potential energy increases. ठीक है? We used formulas to understand it. ठीक है? I didn't use any logic that I had before. It was just formulas. Elastic potential energy increases because the extension in the spring. अगर आपको लगता है कि इस क्वेश्चन में आप मार्क्स ले सकते हो ऊपर वाली चीज़ें लिख के कि टेंशन अनचेंज्ड है या फिर क्रॉस सेक्शनल एरिया अनचेंज्ड है, नहीं मिलेंगे मार्क्स. ठीक है, मार्क्स नई बातों के मिलेंगे. ये वाली चीज़ें कुछ बच्चे कोशिश करते हैं कि ऊपर वाली चीज़ को ना इधर रिपीट कर दें और ये लगता है कि नंबर मिल जाएंगे. नहीं, ऐसे नहीं होता. नई बात लिखनी होती है. इलास्टिक पोटेंशियल एनर्जी इंक्रीजेस बिकॉज द एक्सटेंशन इन द स्प्रिंग increases and you can tell that extension and elastic, बाकी अपनी सारी explanation देते रहो, and elastic potential energy are directly proportional. कुछ इस तरह का बता दो. ये फॉर्मूला लिख दो, EP equals to half fx, कुछ इस तरह का लिख दो and done.